Hey you guys, happy Friday. I just wanted to go over the last set of notes I sent you. Next week we'll have the practice test and our first test. Alright, it says, what is Cpctc? And what that stands for is that corresponding parts of congruent triangles are congruent. Alright, so when you have a proof and they ask you to prove that parts are congruent, and that, you know, when I say parts, I mean like sides or angles. Before you can do that, you first have to prove that the triangles are congruent. So it's going to be like the proofs we did before, but you'll have one extra step, okay? So let's look at the first one. So they give us that AB is congruent to AD. So let's go up here and mark that up. AB, AD. So this segment and this segment are the same size. Alright, the next thing they tell me is that BC is congruent to DC. That is also given. Alright, so BC is right here, and then DC is right here, and they are the same size. Alright, so if they're wanting me to prove these angles are congruent, then I've got to be able to prove that these triangles are congruent. So why can I say that these triangles are congruent? Well, we have two sides that are congruent, and then we have this side that they both share. So I'm going to say that AC is congruent to AC, and that's because of the reflexive property. And we have used that a bunch now. Okay. So I can say that these triangles are now congruent. And the reason why I can say that, so I know that triangle BCA, all right, is congruent to triangle DCA. And that's because of side, side, side. All three pairs of sides are congruent. So side, side, side. Alright, well, since these triangles are congruent, I know that their correlating parts or corresponding parts are congruent. So now I can say the angle BCA has to be congruent to angle DCA. So BCA, DCA. So this angle has got to be congruent to this angle. Why? Because of Cpctc. They're congruent, so the corresponding parts have to also be congruent. End of story. Oh, let me move that. Sorry about the shadow. Alright, let's try the next one. Let me scoot right there. Alright, so we start with PS is parallel to QR. So PS is parallel to QR, and that is given. Alright, so PS, QR. I'm going to draw my little marks to remind myself they're parallel. The other thing they give me is that angle QPS is congruent to angle SRQ, and that's also given. So let's go up here. QPS, boom. SRQ, boom. Alright, now we got to figure out what else do we know just by looking at this picture. Alright, so I know that angle PQS has got to be congruent to angle RSQ, PQS, RSQ. And how do I know that those angles are congruent? And that is because they are alternate interior angles. Alright, and then we also know that they share this side, so it's congruent to itself. So I can say QS is congruent to QS. And that's the reflexive property again. I'm going to abbreviate that. Alright, so I want to say now that these triangles are congruent. So triangle PQS is congruent to triangle RSQ. How do I know that these two bad mamma jammas are congruent? Well, let's look. We have an angle, and a side. So that will be angle, angle, side. And now, since the triangles are congruent, I know all of the corresponding parts are congruent. So that means that PQ must be congruent to RS, and that is by Cpctc. All right, let's do a few more. Whoa. Okay, for number 3, it starts by saying that X is the midpoint. What is the midpoint? What does that mean? Here's WY, that's the middle. So I'm going to say X is the midpoint of WY. That's given. Oh, and VZ, out of room. So if this is the middle of both these segments, I know that it has to be cutting them in half, because this has to be the same as this has to be the same as this. So that tells me that VX is congruent to XZ, and that's definition of midpoint. I also know that WX has to be congruent to XY. Again, the definition of midpoint. All right, what else do we know? What do we have in this picture that we've talked about a bunch of times? We have these angles right here being congruent. So I know that angle WXV is congruent to angle YXZ. How do I know that? What are they? They are vertical angles. Alright, so I can now say that triangle WXV is congruent to triangle YXZ. But why can I say that? What theorem? So let's look. We have a side, we have an angle, and then we have a side. So it is side, angle, side. Alright, since these two triangles are congruent, I know all the corresponding parts are congruent, so I can now say that angle XWV is congruent to angle XYZ because corresponding parts of congruent triangles are congruent. And that's it. Alright, 2 more. Let's look at number 4. So we've got that JM bisects angle Jkl. So JM bisects angle KJL. That is given. Let's mark that up. So here's JM. Here is angle KJL. So that means that this little piece has to be the same as this little piece, right? Because if you bisect, you're cutting it in half. So I know that angle KJM has to be congruent to angle LJM by the definition of an angle bisector. Alright, what else do they tell me? Alright, we got that angle JMK is congruent to angle JML. And that's given. So let's find those. JMK, so that's this one right here, is congruent to angle JML. So that's this one right here. So we have 2 angles. What else do we have that is congruent? Well, they share this butymous side right here, and it is congruent to itself. So I can say Jm is congruent to Jm by the reflexive property. These two triangles are now congruent. Why are these two triangles congruent? So I can say that triangle JMK is congruent to triangle JML, and I know this because we have an angle, a side, and an angle. Since the triangles are congruent, I also know that the corresponding parts are congruent, so I can now say that JK is congruent to JL because of Cpctc. All right, one more. Let's use purple. All right, for the last one, they tell us that BC is parallel to EF. BC, EF, and that is given. All right, it says D is the midpoint. Of BF. All right, so here is BF. D is in the middle. So if D is in the middle, what do we know? I know that this little piece right here has to be the same as this little piece right here. So I can say that BD is congruent to DF, and that is by the definition of a midpoint. All right, so we have some sides. We don't have anything else going on right now. So let's look at what all we have. So I see right here that I have this angle and this angle that are the same. How do I know those two angles are the same? Why can I say the angle BDC is congruent to angle FDE? Who knows? It is by the vertical angle theorem. All right, so we have an angle and we have a side. So I know I just need another angle. What angles can I say is congruent? So I can either do angle, angle, side, or angle, side, angle, actually in this case. Let's go with angle, angle, side. All right, so I can say that this angle is congruent to this angle. So I can say angle C is congruent to angle E. Why? How do I know that? Remember, these two lines are parallel. And then you've got this transversal right here. So these two angles are what kind of angles? They are alternate interior angles. And I know alternate interior angles are congruent. So now we have angle, angle, side, angle, angle, side. So I can say that triangle BDC is congruent to triangle FDE by angle, angle, side. And since these bad mama jammas are congruent, I know their corresponding parts are also congruent. So I can prove, or I have proven, and can say that ED is congruent to CD by Cpctc. All right, you guys, Monday and Tuesday we will have a practice test on Pearson Easy Bridge, and then Wednesday will be the test. I hope you have a fabulous weekend, and I will talk to you later. Goodbye.